Which one's going to be positive? 9's positive. The big one's positive. I like it. And what do you do after this step? Do you just go, I hate when people, all right, so the 8's negative. So y minus 8, y plus 9. Yay! Why do I know that's not right? Y times y is not 6. Oh shit, that's an immediate clue that ain't the right answer. To be honest, that's the way I do it. I just shift factors back, and that just gets weird. It's called a Texas slide, to be honest. I don't really teach that unless you want to see it. Have you ever seen that kind of thing?
No.
No.
Where did the 72 from?
Multiply these together.
Okay.
I like it. Yeah. So real quick, the next step would be, what would I put first? Yeah, negative 8 y plus 9 y. Always make sure that's there. These are just the coefficients of the middle terms. Make sure they actually combine to become this. Without the y's, it don't work. And now you group. I'm going to let you guys finish that out. Is that good enough to get going?
Yeah.
All right. Now, I mean, when I teach this, I teach why we do this. Right, if you want to see that, come to my office. But right now, I'm just curious, are you able to do this? It's a really good question. Why do I multiply 6 by negative 12? Well, you can look up my videos from last semester. Or come talk to me. Yes?
Can you go over 30?
30? Oh, cool. All right. Let me see. I might do that last because it leads right into what we're going to do after this. Yes?
It was 48. It was part B.
Okay. What does h represent in that equation? Height. And what are they asking you in part B?
What time is the ball 48 feet in the air?
So this kind of goes back to a little bit what we talked about earlier with your question, Nathan, about, I mean, here's an example where it's t and h instead of x and y. Just because now it's really easy, time and height. So part B says, at what time is the ball 48 feet in the air? Where in this equation are you going to put 48? In h, because h is height. You wouldn't put it in t. It didn't say 48 seconds or whatever it is. Is it seconds? Blah, blah, blah. Yes. Cool. To be honest, I don't want to assume anything. Somebody's got to be interested in this. This number is truly valid as far as physics is concerned. It's related to how quickly gravity pulls things down. They accelerate. So this is related to the acceleration due to gravity. As you fall faster, don't you? Yes. So you have a parachute, and then you have the whole wind resistance in, and that makes the equation a little bit more gross. So we won't go there. Do you have to understand anything I just said? No. All right, we're just focused on solving the equation. So yeah, just put a 48 there. Now, what the hell do you do with this? They told me 48 feet in the air. Okay, I know h is 48, the height's 48. What do you do next? Good. And why would I put things over this way? Because my squared term is negative currently. I want that to be positive to make this easier. So I'm going to add this over and subtract this over to get it equal to 0, and then you factor. Kick ass. I like it. There's probably some numbers you can divide by to make the numbers nicer. Maybe even 16 to make the numbers really, really nice. You guys see that? So they said, where's the ball 3 seconds later? Then you would have put a 3 in for time. I like it. Well, here they ask me, well, how do you make it be 48 feet up in the air? How long do you have to wait? Then you solve for t. I like it. Yes, sir.
Could you remind me what we do with negative exponents?
Oh, yeah. So the most basic definition is if I see this, it becomes that. And it just means flip. Those 4 m's go down below. That's the basic definition. Right? Negative exponents mean flip. So if I saw this, how could I rewrite that? Yeah, that would flip. All those 8a's would go back up. Don't make it 1 over 8 to the 8. Technically you're right, but that's a disgusting way of writing it. Just make it 8 to the 8. I like it. Okay. So anything, I don't know if there's anything left that we haven't. I think we talked about almost every part of this. Let's see.
And you get 26.
So, so 2t, 2. So, is there anything to do on the inside of this?
No.
No, there's nothing to do in the parentheses. So there's only one thing to do then, the exponents. Who remembers what I said yesterday about what this is telling you to do? It's telling me to flip it. So what would the inside become if I flip it?
1 over t, or 2t.
And what do I still have to do?
2.
Good. I flipped it, and now I square everything. What's 1 squared? 1? 4t to the 6. Beautiful. That's one way to do it, but to me, that's the easiest way to do it. Some of my colleagues think you bring this in, but that gets confusing. Yes?
Is that because it was a negative sign or because it was a 2?
Say again?
Did we do the flip and fraction thing because it's a negative sign?
Yes, because it's a negative.
So regardless of number it...
Yeah, if this first step, if I put negative number, the first step doesn't change.
Oh, okay.
So if it was negative 3, I would have, at this point, I would have cubed it, but this would have still looked the same. The negative part tells me to flip it,
Okay.
and then I still have to square it, or whatever it. I like it. Yes, sir.
The 2 inside of the parentheses, if it had been 2, let's say the third, if we had cubed it, would the 4 have gone to an 8, or would it have gone to a 6?
Okay, let me parse your question.
Because I know
To be honest, so if it would have looked like this.
yes.
Okay. So, to be honest, the way I would do this is just replace this with an 8.
No, I was saying if the 3 was on the outside, we just use that sign. Where the negative is at, if it was to the negative,
Negative 30.
like if it, if it cubed it.
Like that?
Yeah.
Oh.
Where would our end product be a 4? 4 to 6?
Definitely not. Because what would the first step be? How do you flip it, right? So the first step, like I said, is going to look the same. Now I cube everything, and what's 2 cubed?
It's 8.
8.
That's what I was thinking.
Now, the only reason that's a 4 is because it was a square. It was a 2. I like it. But the important thing is that first step. The first step would not change. Negative, I don't care. The negative says flip, and then I apply the other part. I like it. That's to me is the easiest way to look at it. There are other ways to look at it. Teachers teach it different ways. We have different opinions. They're not necessarily wrong. I'm just a little more right on it. Just for me, it makes sense. But what matters for math is to figure out what makes sense the most for you. Okay. I must have assigned, please tell me I assigned some of the word problems. Nobody's asked me anything about the word problems.
Only 40.
48 is not really a word problem, to be honest. A word problem is where you got to make your own equation. So if they give you an equation, that's a plug and chug. Who cares? That's easy. Yes?
44.
See, now... All right. So what I'm going to do, just to be an asshole, is I am going to do one that I didn't assign. Because I have this weird feeling not everybody has done this yet. Let's see. Ooh, that's awesome. Let's do this one. 45. I like it. Because I do have like a word problem handout that I give out to my classes. I could post that to the website. But word problems, hopefully they kind of did a decent amount of them in your Math 90 class. We're going to do a lot more of them in the 110 class, so it does become kind of important. So number 45 says this: in an isosceles triangle. Let me stop right there. What's that mean?
Triangle that has 3 equal sides.
No, that's equilateral.
All the sides are different.
No, that's
One side are the same, right?
one side is different than the other. So 2 sides are the same. All right. So isosceles, the standard way to draw an isosceles triangle is like that. So let me ask you right now, how long is this side? Oh, I don't know. Do you have a ruler? No. I mean, do you know how long the side is? So you do know how long it is. How long is it? X. I love it. So how long must that side be? That's the idea of isosceles. I love it. So that's all I know so far. From one word, I drew a triangle and I made two of the sides the same length. That's the only time you can call two things in a problem the same math name is if you know they are the same. If I said Fred makes twice as much as Bob, and you say Fred is X and Bob is X, what the hell? Somebody's going to be angry, right? Fred's going to be like, wait a minute, I'm supposed to make twice as much as Bob. I know twice as much as him. That's Fred. Fred's an asshole. Oh, I'm sorry. My imaginary Fred. Now here we go. So, they tell you. That's all right. They tell you the measures of the two smaller angles are equal. So we're talking about angles here. So let's come back. How big are these angles then?
20x.
We don't know. They don't tell you. Don't worry. Yeah, if this one is X, this one's also X. I like it. If one opens the same amount as the other one, then the stick between them is the same size. Always think about putting a stick in some monster's mouth.
Why?
No. Oh, why put it in their mouth? So they won't eat it.
Sorry.
Their sum is 20 more than the larger angle. I like it. So if we can certainly call this one Y. We can't call it X because I don't know if it's not the same size. But what do they tell me about this? They tell me that angle is, let me see. The sum of the two smaller angles is 20 more than the larger angle. So the sum of these two smaller angles is 20 more than this. Can you write that, what they just told me? What would it look like?
X squared plus.
Careful.
X plus X plus.
Yeah, the sum of these, not the product. So X plus X, the sum of these is 20 more than the larger. I like it. So 2x is y plus 20. Let me stop there for a second.
Or 2x minus 20 equals y.
Keep x. I like it. And we like that because we only want one variable to work with, so I can solve for it and be done with it. So I don't want all these. What is y, though? Like Nathan just said, if you subtract 20, you get y is 2x minus 20. Let me stop there for a second. So what I just did was, this was a very visual problem. It's a geometric problem. I could draw a triangle and kind of work with it. Now, if you're a student from Math 90, you could also, if it's not so visual, you could say, I got two smaller angles, and they're X, and I got a bigger angle, and that's Y, and then you can do stuff, right? You got to tell me what the players are in the problem and give them math names so they can work with them. That's how you work with a word problem. I like it. So now, what do I know about angles in any triangle, at least in the geometry we use?
Equals 360?
No, that would be angles in a rectangle or quadrilateral. So if angles in some quadrilateral have to add to be 360, angles in a triangle have to add to be 180. I love it. That's a nice quick proof of that. So if I take this plus this plus this, that should equal 180. And there's your equation. Now that should be the easy step. Once you get your equation made, you're like, oh, thank God, that's over. Just got to solve this and I'm done. Right? So this angle plus this angle plus this angle has to be 180. The mistake people make is they skip drawing a picture, they skip giving things names, and they go, I see 20 more than something, and I know the angles make 180. Oh, look at that. That's crap. One angle by itself, not even correctly written, equals 180. That's impossible. You've got to tell yourself what's involved so you can make sure everybody's in the equation that has to be there. Yes?
So now I have 2x plus y equals 160.
What happened?
Your next step.
There should be no y's in here.
4x.
Do you see that? Yeah, 2x and x is 4x minus 20 equals 180.
So you got rid of the y by substitution.
So I want all of my angles to be related to just x. So they have an equation that only has one variable in
That's
it.
what I guess I was wondering what to do with
Gotcha.
that.
So right here, after you told me this, subtract the 20 and know what y is. Y is just 2x minus 20.
substitution, you got rid of what?
Just by solving, really. Yeah, substitution. Sure. So you can say that y plus x equals 180, but y is this. Substitution, I love it.
Okay.
So I didn't even look at it as a system of equations. I just immediately made everything in terms of x. But I don't want to work with an equation that has more than one variable in it because I'll never solve for anything then. I do want to get just one variable left over at the end.
Yeah, that's all guessing.
Guessing? No.
I've done it before. But it's only a real simple problem. So I mean, it's something you can figure out in your head pretty much already.
But see, this is in no way guessing here. I mean, this is translating from English to Mathish, right? They told me the sum of these two angles is 20 more than the biggest. So then I can immediately subtract 20, and I know that the biggest is 2x minus 20. Okay. Yes?
So I went through the 4x.
Oh, I know what you're talking about there. All right. Don't do that.
So I continued the 4x minus 20.
Yes.
180.
Sure.
And it came out x equals 50.
Sure. I like it.
Okay, so if I did x...
Right, because you add 20, you get 200. And make sure everybody's on the same page. X is 50.
Okay, so you said those would be the two bottom angles, 50 and 50, correct?
Totally.
Okay, but it says x, the top one's 20 more.
No. What is this guy? We put it for ourselves right here. Y is 2x minus 20.
Then I put 50 in there?
Twice 50, 100 minus 20 is 80. 80 and 50 make 180. Thank you. I like it. So be real careful. They told me that the bigger one, the sum of the smaller ones is 20 more than the bigger one. See, they never told me directly what the bigger one was. I had to solve for what the bigger one was.
So you got the equation for the top angle.
Yeah, exactly. Use the equation for the angle to figure out what the angle
That
is.
is substitution.
Yeah, substitute in what your x was for that. I love it. Okay, cool. Now, obviously, that's one quick example of a word problem. I can bring in that worksheet, or maybe at least post it to the website. And it kind of has two examples really drawn out about how to set up a word problem. Fewer and fewer students seem to be able to do word problems. And I think it's because more and more teachers are shying away from doing a lot of them, which is dumb. Right? I have complete faith in your ability to understand how to do a word problem. You just have to be given the chance to do some. Right? I just don't think that we're possibly giving you guys enough chances. I don't know. Yeah, the Math 90. Anybody just take Math 90? Did you guys do a lot of word problems? Or not much? See, there you go. Fear is confirmed. So Math 90, we didn't do like a ton of them because that's not the main point of 90, but it is an introduction to word problems is what Math 90 is supposed to be. So maybe I will bring in that worksheet tomorrow. We'll work on that a little bit. Because, word problems are going to be in this class all over the place. And it's not because we don't like you. When we're like, let's put some shit in here we know they don't like. It's because real freaking life is taking numbers from a situation and using them correctly. Which is what a word problem really is. Somebody have their hand up? Everybody cool? Okay. Is there anything left over from anything at all from chapters 1 through 6?
There was that one version of the last, we were reading through last, the long version of the...
Oh yeah, because that's going to lead me into today's discussion, but I'm just thinking in my brain if I want to... Do you want to do that first, and then we're going to take a field trip, and then I'll give you an extra 15 minutes on that for a break? Yeah, let's do that. So let's do this synthetic division weirdness. We'll take a field trip. A little break after that, and then we'll come back and do a little bit more chapter 7. Sounds like a plan. All right. Yeah, field trip. Don't get too excited. We're not going to Dublin or the Natural History Museum, sorry. What's that? I promised the Natural History Museum? Was I? I was high, I'm sorry. Alright, so I've got a little handout, but let me get into this a little bit. Let's first remember how just long division, just saying this must hurt you, I'm sure. Long division of polynomials. You guys remember that fun stuff? Yeah? So for example, if I said, that. do this, like I want to do. So remember, variables are numbers. They have to act the same way numbers do. And let me show you a little side example. Sure. So if I was going to do this, long division, right? I set it up. Does anybody not set up the long division like that? Anybody come from, how do you set it up? Do you?
Just that way, or it's the other way, it's sideways.
Alright. So as long as you understand how to do this method, okay. Because sometimes I think it's Russia and some European countries, they set their division up entirely differently. And actually, to me, I think it works better. I just always have to be shown. I forget how it works. So is everybody's cool with how this setup works? Okay. All right. So what would be the first thing you would do here? I love it. Kick ass. You guys have stepped right into my track. So not a track, really. It's just explaining why that works the way it does. And the students don't seem to understand why that does, and I don't blame you. But do I look at the whole 91 and the whole 8? No, screw that. I look at 9 and 82. The first parts of them to give me an idea what to start with. And of course, what would that be? 9. Because 9 goes into 82 roughly 9 times, right? And then what do you do? 9 times 91 is?
819.
819. And then, do I leave the 819 as a positive 819? No, I make it a negative 819, right? Some of you guys are like, no, we subtracted. Well, that's what subtraction is making it negative. Right? I'm saying it for a reason that weird-ass way. You know, like, come on, math dude. Don't make subtraction hard. Sorry. And then, of course, you subtract. So you get 8. And then, how would you write that? Don't put big ass R. We're way past that.
98 over 827?
Over 91.
Yeah, what we divided by.
Oh.
Yeah. And of course, what do we understand is in the middle here? We talked about it a little bit. There's like an understood plus sign in there. Okay. So we just ran through what should be arguably a very simple problem. Some of us haven't done long division in a while, but still, it should come back to you pretty quickly. So we do the exact same thing, believe it or not. I know you guys don't believe me, but I don't care, because it's true. Right? So we put this there, we put this there. The worst part of this is the amount of writing you have to do. The x's don't matter worth shit. What matters are the numbers, the coefficients, right? And that's the whole point of synthetic division, is to just focus on the numbers and not write as much. So what gets me started? Remember, we didn't do 91 into 82. We did 9 into 82. So here I do x into x squared. Same exact way. X times what is x squared? X. So then I get x squared
minus
2x.
minus 2x. And then what do I do? I change the sign. Yes?
Why did you say minus 2x?
X times x is x squared. X times negative 2 is negative 2x.
Oh, okay.
Yeah. So what do we do here? Did I just do 9 times 9? No, I also did 9 times 1. You got to do this times this whole thing. Right? I mean, that's the process. Now, it doesn't care that you just used the 9 to figure out what to try first. You got to multiply that by the whole damn thing. That's whatever's there. All right, so that times this and that times this. Bam. And then I change the sign. Let's see if you work. Oh, okay. No. So you change the sign. Bam, bam. These go away like they're supposed to. And then you get negative 2x plus 7. X times what is negative 2x? X times negative 2 is negative 2x. I mean, do you guys... It's the exact same steps. Exactly the same steps. It's almost creepy how the same it is, even though it looks so freaking weird. X times that is this. So that's why I put that there. Negative 2 times x is that, amazingly enough. Negative 2 times negative 2?
Plus 4.
Plus 4. And then I change the signs. So I get...
3.
So how do I write that?
3 over x.
Plus 3 over x minus 2.
Always plus. Always the sign.
Yeah, you can always put plus, and then you can put, if it's negative, you just put it up there if you want to, or you put the minus there. Yeah, you got some flexibility there.
Totally with you there, but for this problem, it's 3x to the 4th power. That's where I get a little lost.
I'm working my way up to your problem. Yeah. So your problem has a couple things different, or at least one thing, if you remember. Yeah. All right. So this is why I had to do this problem first, because yours has a couple weirdness things. Yeah.
What's the name of this?
This is just long division. Same thing as that. So just because there's variables in there doesn't change the process. So it's still long division. What do you say? Long division of polynomials.
My teacher didn't use any of the terms, so I'm trying to.
Oh shit.
Yeah.
So they skipped word problems. They didn't use terminology. Oh, I'm sorry. Yes.
Okay, so after you got negative 2x plus 7, what did you do after that?
So
the negative 2.
if this would have had another number here, real quick, if that would have been another 9, I would have brought the 9 down, right?
Yeah.
And then you would have said 91, you would have to actually go to 0, whatever. But you still have to look to see how many times that goes into that, whatever that is. So that's what I did. X times what is negative 2x?
Negative 2.
Negative 2. So real quick. Let me do this again real quick here. X times what is x squared? X. X squared minus 2x. Change the sign. Okay, is everybody cool so far? Okay. Then you add, those go away, that becomes negative 2x. You bring down the plus 7. X times what is negative 2x? See, so x times what is this? X times what is this? X times what is this next thing? The process keeps going because that's exactly what we would do with numbers. Same process. I like it. Yes?
Let's go back to the homework. Are we allowed to do the long division always? Because
No.
30 is... You should try.
30 you have to. So
You have to.
we haven't even talked about the other method yet. So let's talk about it. Well, let's do number 30. We'll talk about the other method and when it can be used. Okay. And the synthetic division method I'm going to give you, it's not going to be a huge part of this class. If you're going into pre-calculus and maybe to calculus of some kind, it will become a huge part of your life. Or, a decently large part of your life will be synthetic. So I want to introduce it to you now, so it's always kind of there. The problem in the homework has a problem. It's missing one of the terms. So let me be really dumb here for a second. If I put the number 907, what's the 9 mean? 900s, right? What's the 7 mean?
7.
And what's the 0 mean? I ain't got no 10s. You with me? 0 10s. Right? If you want to say it grammatically correctly. So when I have a problem like this, what was it again? X cubed minus 3x?
3x.
3x cubed minus x. Ooh, it's even prettier than I thought. Okay. So long division will work on any ratio of polynomials, as long as the top power is more than the bottom, or at least as big as the bottom power. All right, let me stop there for a second. Okay, maybe. Okay. Synthetic division will only work if the bottom is x plus something or x minus something. That's the only time synthetic. The new thing we're going to talk about later that we haven't talked about yet. It will only work in that case. So here I would have to do long division. And most of you guys are like, that's fine because that's all I know right now. But when I write this, does anybody know? There's a reason I just did the 907 thing. What is it that I'm missing? So when I go to write this, I got 3x cubes. No x squares. I want to have a placeholder here. To have a place to put my x squares in case I have... maybe I won't have any, but I probably will. Huh?
Why is the... Why put 0 in?
Well, it's the same thing. If I didn't use a 0 in 907, people would think I'm saying 97. So, I'm saying that I have none of these. Let's start this off. Let me show you where things would go bad if you didn't have it. What's the very first step here? Good. So x squared times what is this?
3x.
3x. Cool. All right. So everybody see where that 3x came from? You're like, yeah, you just wrote it. No, I watched you do it. All right. 3x times x squared? It's got to be the same as that or else you made a mistake. Right? 3x times 1? 3x. So that goes away with it. So far you're like, what the hell, Jeff? I understand. So then you do what? Change the signs. Okay, so you get these go away, no x squares. Minus 4x plus 1. Now the reason I put that there is in case there was more going on. Now in this specific problem, you're not going to believe me, and I'm okay with that too. I put that there in case I get x squares, I have a place to put them. Did I get x squares? No. So I didn't really need them. I didn't need that place, but we got lucky on this one. If you forgot it, you got lucky. But always put a 0 if you're missing something.
I'm not going to accuse you, but did you steal a chair out of my desk out of my class?
Totally did. Do you need it back?
I need one.
Oh, okay.
No, that's okay. I'll get it tomorrow.
Are you okay right now?
Yeah, fine. I'm done. But I was in there. I go, hey, I got 50 people. I only got 49 chairs.
I'm sorry, buddy.
I knew it was you.
You should know it's me, because I have a bad memory, and I steal stuff. Yeah. Sorry, Jim.
It's okay, buddy.
See you.
Full class in here, pal.
Huh?
You got a full house.
Yeah. Well, except for one. I could have actually brought it back if I would have remembered. See you.